Hello and welcome to Food Safety Fridays. My name is Simon Timperley from the International Food Safety and Quality Network. Today's guest is Adam Green, Market Manager, Mettler Toledo's Safeline X-Ray. And today we're going to be talking about meeting retailer requirements with X-ray inspection. We're a little bit delayed, apologies, a few technical errors, but we're here now. So welcome, Adam. How are you doing?
I'm very well, thank you, Simon.
Good. And where are you joining us from today, Adam?
I'm joining from Cambridge in the United Kingdom, so near our manufacturing facility in Hertfordshire. Very
nice. And I'm up in near Manchester in the UK. And tell us where you'll see in the sidebar, Adam, in the chat, Cindy, Pennsylvania, Harvey from New Jersey in the USA, Jamal from Algeria. Where else have we got? Dover in the UK, Steve Brown, Sam Brita from India, Elaine from Toronto. Yeah. Tell us where you're joining from. People will be joining because I've just sent another email out to give people the link. So while we're waiting for the come, we'll play the sponsors ads, and then we'll be back for Adam's presentation shortly. Okay, I really like that new ad from Mettler Toledo, who are one of our kind sponsors of Food Safety Fridays, and hosting today's webinar, Meeting Retailer Requirements with X-Ray Inspection. If you do join, if you've just joined, this is recorded today. You'll get a copy of the recording, the slides, certificate of attendance by email half an hour after this webinar concludes. But for now, I'll hand you over to Adam.
So thank you very much, Simon, and welcome to this webinar on how X-ray inspection can help retailers meet requirements. So we're going to take you through some of the agenda. So first of all, we need to clarify what are these requirements from retailers. Who are they? What necessarily is being pushed down onto food manufacturers? Then we're going to look a bit specifically how X-ray in particular can help with retailer requirements. We're going to look at some of the visual management advantages we can provide from the equipment from Mettler Toledo. We're going to have a look at how some of the elements of the machines can help support quality processes, and then finally just touch very briefly on service offerings, because this is obviously a vital way in which we can keep equipment running for our food manufacturing partners. And at the end, obviously, we're going to come to a Q&A session where we can hopefully answer as many questions as you could possibly have come up with. So if you do have any, please make sure you put them in the chat, and we'll make sure that we come back to you either straight away today or after this presentation. So in order to sort of clarify the presentation in terms of meeting retailer requirements, first of all, we have to formalize our understanding of what a retailer is. So fundamentally, we would define a retailer as a business that sells goods to the public in relatively small quantities for consumption or use, rather than selling on to another entity. So in terms of meeting retailer requirements, we're going to start with what we would classify as global legislation. And there are three types of legislation that we're going to go through during the presentation. There is global, there is regional, and then there is local. And the reason that we're starting with global is fundamentally the GFSI, the Global Food Safety Initiative, was formed back in May 2000 by a collaboration of international retailers. So obviously the formation of this entity was by retailers in order to essentially enhance the topic of food safety. This global organization now reviews food safety standards and approve those which meet a specific criteria. If we look at some of the necessary schemes, the foundation that makes all of the GFSI standards is very much focused around good practice in food hygiene and manufacturing. And a lot of that is focused around this topic of HACCP, so the hazard analysis of critical control points, and other types of prerequisite programs. So we do have, if you do want to find more information specifically about HACCP, we do have some more information on a white paper which we can share. But to move on, we're going to focus on look at some of the GFSI recognized schemes. So these are necessarily global programs that retailers are looking to, via the GFSI, pass on to food manufacturers that serve the general public. So within that, we've got the BRCGS, the British Retail Consortium for Global Standards. We've got the Food Safety System Certification, the FSSC 22000. We've got the SQF Institute, and of course, we've got the IFS as well. And generally speaking, these four schemes form sort of 90% of all the adopted standards. And realistically, all food manufacturers should consider these as a minimum requirement to food safety. Now, of course, we're not going to spend too much time today going through each of the necessary standards within, but essentially common to all these standards is the aim for all food manufacturers to provide a processing environment which minimizes the risk of product contamination. This is an essential component of a food manufacturer's due diligence when it comes to producing their product. Now, we're just going to touch briefly on three examples of some of the food standards within the GFSI. So here you can see three that we've selected, one of those being the BRCGS Food Safety Issue 9, where fundamentally, as part of a documented assessment within an overall food safety plan, fundamentally each manufacturer needs to identify the potential use of equipment to detect or remove foreign body contamination. Now, you'll note that there is not a specific requirement for a certain piece of technology, and this is necessarily a common theme. However, it does provide some level of guidance in the sense that typical equipment to be considered may include metal detection and X-ray equipment. So here you can see fundamentally that there is a potential that this kind of foreign body inspection equipment can be utilized to ultimately provide the necessary protection for food manufacturers. If we necessarily look at the FSC, obviously it's a certification model, but again, this comes down to offering certification schemes for the auditing and certification of these food safety management systems to ensure the provision of safe food, feed, and packaging to the consumer goods industry. Again, if we touch on the IFS, it's very much focused around a food manufacturer's ability to produce safe food. And there's the common level, shall we say, across the board, which is all about focused on product safety for the end user. Now, let's focus on what are some of the requirements. So, generally speaking, there forms two categories. There is specific values that have been specified by certain organizations, and you can look at some of these potentially as regional governance when it comes to, I'm going to start with North America. So here you can see very specifically that the FDA have specified a value in which is deemed hazardous, and therefore you need to, as a food manufacturer, working within that level of governance on a regional perspective within North America, ensure that your food safety process captures potential risks of either 7 millimeters or 25 millimeters in length. So this is the specific example of regional requirements that a food manufacturer might be required to work towards. Again, sticking with North America, you can see that Health Canada provides a different requirement. For example, Health Canada evaluates in material and considers 2 millimeters or greater as the threshold size for a consideration as a health risk. And of course, within that, there are going to be certain caveats, such as infant food, where obviously, due to the biological nature of those individuals, smaller sizes are also potentially going to be considered a risk. And this is where, again, particularly for those of you necessarily in North America, this is the sort of values necessarily and the regulations either from retailers or from regional governance, which food manufacturers have to adhere to in order to ensure food safety. If we look at it from a European perspective, again, continuing on that regional trend, the European Food Safety Authority has adopted a slightly different principle. And sometimes you'll have heard it referred to as a LARA, sometimes you will have heard it referred to as a LARP. Fundamentally, regardless of the initials, it comes down to the same thing, where fundamentally it's about detecting the smallest foreign body size that can be reasonably achieved. And obviously, this goes some way into following good practices at all stages in the manufacturing process. Now, we would necessarily distinguish that there are three key areas in terms of the manufacturing process. You have front-end inspection, and this is where necessarily you have raw materials coming into the factory, ready to be processed into whatever the final good may be. You have in-process inspection, and this would be along the manufacturing process, but not yet at the final end of the line where the good is complete. And then finally, you would have end-of-line inspection, where we have our final package, and therefore these are the three key areas in terms of or three parts of the process in terms of the overall food safety journey. So how do you control contamination? Well, first of all, each manufacturer will need to analyze the potential risks of their product's journey. And then as part of that, they could look to eliminate, and there could be lots of different ways in which they could look to eliminate. They could pass some of that responsibility onto their suppliers, potentially, to remove foreign bodies. But it may not be possible to eliminate all of the potential risks that might come in from the raw ingredients. If that's not possible, then we need to look at ways to potentially prevent these risks or hazards from entering the product. And you can see this from PPE, for example, where we're looking to prevent the risk of human hair in terms of getting from an individual into the product by the requirement to wear PPE, as an example. But if we can't eliminate it and we can't prevent it due to whatever reason, then we need to potentially look and identify how to control the risk or hazard to an acceptable level. Now, if we think of the general manufacturing process, controls such as magnets, screens, sifts, and filters can be used along with electronic solutions such as metal detectors and X-ray inspection equipment. And these type of technology can be implemented throughout the three key areas of the manufacturing process in order to help control contamination to an acceptable level. Each and every one of the solutions has a purpose, and it's important to understand not only the capabilities, but also the limitations. And this is where, obviously, we're going to be focusing more specifically on X-ray technology in terms of the benefits, the capabilities, but also some of the limitations as well. So how can X-ray specifically support retailer requirements? So fundamentally, X-ray inspection can support food manufacturers with their risk assessments and their ability to provide safe products by providing a type of equipment that can inspect a wide range of products and also a wide range of foreign bodies. At this present moment, X-ray inspection provides the most complete solution when it comes to foreign body detection. However, that does not necessarily mean that it can remove all potential risks from the manufacturing process. So if we think specifically about other types of inspection equipment historically been utilized, this is where X-ray and its capabilities can offer manufacturers an advantage. And this is because the ability for X-rays is to inspect materials that go beyond metal. So I've got some examples here: shards of glass, stones, bones, and of course there are other low density materials which we will touch on. And this is why, because it can go beyond metal detection and inspect a wide range of different materials, this is why currently X-ray is seen as the ultimate when it comes to product safety in the manufacturing environment. Now, not only can it inspect a wide range of potential risks, foreign material, but the technology itself, because of its guiding principle, which is all about density rather than conductivity, X-ray technology can inspect a wide range of packaging types. And you can see I've put a few examples on there in terms of visual images, but also a description of some of the different types. So aluminium foil, metallized packaging, plastic pouches, cardboard, glass, to name but a few. And again, going back to that previous point I made about it's all about absorption rather than conductivity, X-ray inspection is not impacted from a sensitivity perspective when it comes to wet or dry formats. The X-ray, because it's not impacted by conductivity, is not going to get the level of challenge in a manufacturing environment where potentially we have a frozen product and due to a line stoppage, the product begins to thaw. X-ray is only impacted by a product's change in density. And for this reason, it can cope in an environment where there are some challenges, especially where we have that crossover between wet and dry formats. So we're very briefly going to touch on the science behind the X-ray. So X-ray, for those of you that don't already know, the actual X-ray beam, which is the key element of the technology, which is produced by a tube inside what we refer to as the generator, sometimes also referred to as a tank. It is a type of radiation, but it is a man-made type of radiation. So obviously, products passing through will go through the X-ray beam. The good news is that those products that pass through the X-ray beam do not become radioactive. And this is because the products that go through the X-ray beam are interacting for such a small amount of time that it does not allow for essentially that product to build up any level of radioactive nature. For some level of context, it would be the same as an individual going to a hospital for a chest X-ray and fundamentally after that chest X-ray, them not becoming a radioactive entity. There have been lots of studies into this. For example, the WHO have confirmed that food radiation levels up to 10,000 GY do not affect food safety or nutritional values. So there is a lot of room to play with, because if the food was subject to radiation, roughly 10 times bigger than what we use in our X-ray inspection systems, the food would continue to remain safe. So not only is there the safety element of the food that is going through the X-ray is not impacted when it comes to becoming radioactive, there are also strict controls about the type of safety when it comes to having an X-ray machine in a manufacturing environment. And the good news is, of course, as well, that has been well studied and well documented, that safety in terms of operator safety of having an X-ray machine in the operating environment does not impact those to any significant level. And that's why it is generally accepted as safe to have an X-ray machine in the manufacturing environment. So now we're going to have a look at how the visual management of the X-ray can help manufacturers with the requirements from retailers. So fundamentally, an X-ray system's primary purpose is to provide foreign body inspection. And one of the ways in which the machines from Mettler Toledo can help is by the visual management that the algorithms allow to showcase the foreign body detection. So what you can see in the bottom right-hand corner is a representation of how the system showcases the performance of the X-ray. And what this allows for, whether it be a product test, whether it be as part of a audit trail where someone has come onto site and is looking at a process for foreign body detection, they can clearly see as part of that test the foreign body going in, and then the level of detection that that system can perform. And this is one of the ways in which the software can really help food manufacturers when they're then potentially going and meeting the necessary requirements from retailers. So, for example, if we think about some of the local challenges that might be, there are specific retailers that might have a code of practice which specify the size of foreign body that you have to achieve in order to supply them. This is a common practice, for example, in the United Kingdom. And therefore, this is where the ability for a food manufacturer to have an X-ray on site, pass through the necessary test piece, which is stipulated in the code of practice, whether it be product height, whether it be product consistency, and then show to an auditor that potentially not only could they achieve the foreign body inspection, but also that they could potentially actually find smaller to obviously guarantee higher levels of protection. And this is where the visual management of the software helps those manufacturers in those particular examples. Not only that, the software that we utilize in terms of getting the X-ray inspection equipment from having nothing to having a fully set up product is very much automated, which means that food manufacturers can very quickly and comfortably, in most cases, with a very straightforward setup of generally 5 minutes long, can put themselves in a position where not only can they have their product set up on the machine, but they could be then demonstrating the necessary compliance at that local level, should there be those stipulated values, or from a regional perspective like the FDA. Again, following the principle of visual management, there is certain features on the machines which ensure that the X-ray is following, again, these codes of practice. And a lot of those focus around the ability for the machine to not only inspect, but also remove a potential foreign body from the line and ensure that it goes into a lockable environment. And this is where we have a range of options that allow for food manufacturers to do exactly that. They can follow retail codes of practice and ensure that any product that is deemed as contaminated can go into a lockable bin and therefore can be essentially disposed of in the event of the customer's process. But not only that, you can see that we also continue the theme of visual management by allowing that the operators in the manufacturing environment can pass by the machine and see whether that bin is filling up. Because again, if we think about some retail codes of practice, part of the elements that ensure the meeting of these requirements is to ensure a series of fail-safes, such as if the product bin is full, at the point of next rejection, the X-ray needs to go into a stop condition. This, of course, is going to impact negatively on the manufacturer because it could result in downtime. By having this ability for the X-ray system to show how much product is in the bin, it allows for the operators to have a chance to interact with the X-ray and prevent them from getting into a condition where the line has to stop to meet the requirements of the retailer in the event of a full bin. So we talked a little about the primary purpose of X-ray. Again, it's about foreign body inspection. But X-ray can do much more than just product safety. This is where X-ray can go beyond and offer the highest level of overall brand protection. And the reason for this is because we have an image as part of an X-ray machine. And what that allows us to do is do additional checks on a product that can prevent not only foreign body complaints, but also other types of complaint as well. For example, here you can see some examples of the types of check that can be done on product that help improve the overall quality of a product that is going to be sold by a retailer. For example, you can see that we're performing a completeness check on the first example of our box of apple pies, counting to make sure that we have the correct number of potential complaints. Secondly, you can see from a similar principle, but this time it's an overfill or underfill. Well, this has two primary purposes. One, from an underfill perspective to prevent against potential complaints, but from an overfill perspective, it's also there to help the manufacturer with their profitability by disabling giveaway. For those products that are particularly challenged by shelf life, there is checks that can be performed on the X-ray to ensure we get the maximum shelf life from those products. And this is where, for example, a product trapped in the seal can become very important, especially on high risk goods such as protein, where quite often, if the seal is void by something being in the seal, then now, of course, there is a risk that that product can be spoilt regardless of the expiry date that is written on the product. Again, the next example you can see, we have the ability to combine functions of the completeness check and the fill level. So here's an example of a box of chocolates. We can see that we're counting each one of the individual chocolates. And not only that, we're performing a overfill or underfill check of each individual chocolate inside that box. And this is where it can potentially, again, have an advantage as whether one is over in one compartment and one is under in another. This could potentially not be rejected by other types of inspection system, but to an X-ray, it could be deemed a failure. So this is a way in which X-ray can really help protect those potential complaints from end users that ultimately end up with the retailers. Clip detection. So again, there are some products in the food manufacturing industry that again require clips in order to seal the product. And therefore, what an X-ray system can do is actually identify the presence of clips, going back to that topic of shelf life, but also the tool itself that has been written enables for that clip to be removed from the image so that foreign body inspection can take place inside the overall diameter of the product, excluding those areas of the clip, which is something that is not available with other types of inspection system. Now, of course, having benefits to the X-ray system works well in an environment where it's easy for the operators to be able to get the best out of the machine. And I mentioned previously that the setup of products can be defined as automated. Anybody, regardless of their experience with Mettler Toledo equipment, would be able to set up a product in 5 minutes following the prompts on the HMI. And this is particularly important when it comes to manufacturers that have high staff turnover or seasonal workforces. But also, because the ability of the software algorithms to set themselves up automatically, it also allows for the reduction of training of staff, and also the ability of the system as part of the process to try and fine-tune to the lowest false reject rate possible, which of course is going to help with the productivity, which is then going to help them meet the demands of the necessary retailer that food manufacturer has in terms of getting them the necessary volume. Now, of course, if we have an X-ray machine on site, we need to ensure that the system is running in a manner which is repeatable detection levels. And this is where there are programs such as the performance verification routine, which can form part of the audit trail, which again goes a long way into meeting those retailer requirements. Most auditors, whether that be on a global level, such as the BRCGS, or a local retailer within the country, will like to see the records of a PVR to ensure that the necessary food manufacturer is routinely testing the equipment to ensure that it can continue to maintain the level of safety agreed in a contract. With X-ray systems, especially from Mettler Toledo, this PVR function can be set up so that it runs on a count basis, so every 10,000 packs, on a time principle, which could be every shift, or whatever the general process would be. Quite often it's seen on an hourly basis, as this continues the trend from metal detection systems. However, it is important to note that X-ray systems do not drift in their sensitivity over a period of hours like a metal detector can do. From an X-ray perspective, drift is very much over a period of years. But these tests can be run in live production, or they can be run in an offline at the end of a shift or a batch. And the routineness of this is electronically recorded. And again, this is against the pass or fail criteria, and this can help a food manufacturer provide a paperless audit trail for whoever might be coming in to review their process. Not only that, but once you have made the choice of investing in X-ray technology, you also need to make sure that once the system is installed and the values of sensitivity meet the necessary retail requirements, you need to ensure that those menus can be protected from potential changes such as operator intervention. And this is one of the things that we've been developing to ensure that we can essentially lock off that gold standard post the commissioning phase. Now, we call that the product validator. And what the product validator does is it essentially removes the ability for anyone but that specific user to manipulate the sensitivity values, providing high levels of protection to the necessary individual who might be on site, a food manufacturer, so that fundamentally, once set up, the parameters cannot change. And this is displayed by the green tick within the shield on a particular product menu. The good news is that in the event that that password gets shared and someone does manage to make a change, the product validator acts as a Windows restore, or like a Windows restore point, where you are very quickly able to jump back to the previous values, which again is going to limit the potential damage those changes could be made. And here you can see an example of the software settings being locked out. You can see the X-ray image within the folder has been validated, i.e. it is running with that green tick. And of course, one of the most important things when it comes to the technology is within the change logs, so the event log, anything and everything that is done on the X-ray is fundamentally time and date stamped to allow for that audit trail to understand who is doing what functionality or what potential changes on the machine. So when it comes to matching some of those codes of practice, of course, because we have our image, we need to be able to do something to demonstrate in the event of a potential challenge what those next steps are. What are those reactive reactions going to be to improve the overall food safety? And this is where the ability to store contaminated images provides that high level ability for audit trails to be met based on the fact that if there is a contamination in that contam folder, corrective actions can be applied and demonstrated to the auditor about how the ever developing food safety process is changing based on the requirements of the X-ray to obviously identify foreign bodies within the product. These, of course, can be searched for, and as well, we can provide product statistics as part of understanding that productivity for the machine. Now, when it comes to supporting the information that the X-ray can provide, one of the ways in which we can from Metla Toledo do that is by providing a platform that will allow multiple pieces of technology to provide all the valuable data. We call this Prodex, and fundamentally Prodex is a compliance management system that allows for all of the Metla Toledo product inspection equipment to be within one software platform. So for example, within Prodex, you can see the frequency of the MD, the X-ray, the checkwear, or the vision system, how frequently those PVRs, those performance verifications or performance verification routines are being conducted. You can have those reject images go into Prodex, and then a corrective action can be noted down in the software so that when an audit is taking place, again, this can be demonstrated to them in order to ensure that they are meeting the necessary compliance requirements. And of course, not only that, the software is able to perform additional functionality such as highlighting whether equipment is running and send warnings in the event that there is a potential error or challenge on the machine, such as the bin full example that I gave earlier. So before we jump into the Q&A session, we just wanted to touch on our final topic, which is all about how can fundamentally the service offerings help food manufacturers. Now, of course, it's going to come down to ensuring the machine is up and running for as long as possible to ensure that the goods that are running through the manufacturing process are, of course, being inspected and therefore within those potential codes of practice and retailer requirements. And the ways in which we can do this is we have a range of service offerings that we can provide from Metla Toledo. We have the ability to, as part of a contract, visit routinely in order to perform diagnostics of the equipment to make sure the machine is running at its optimal levels and potentially therefore recommend any potential, whether it be spare parts, if anything in particular might be showing as a potential up and coming failure mode. Not only that, we also offer 24/7 support in terms of the ability to pick up the phone and phone our Follow the Sun program, where there is essentially English speaking support in various locations around the world throughout the period of the day. In terms of ensuring the maximum amount of uptime, we have spare part kits, and we also very proudly offer a 5-year warranty on the generator. And this is because through extensive data, we can understand that the machines don't fundamentally drift within that period, and therefore we can have a high level of confidence that the manufacturer that is investing in the technology can have peace of mind over that initial 5-year period. Now, I do appreciate that we were running a little bit late today. My apologies for that. We did experience some technical issues like Simon mentioned. But what I'd like to do is thank you very much for you joining today's session. I know it's a very high level information. And of course, we would welcome the opportunity now for you to essentially join the Q&A session, ask any questions you might have. And of course, we'd be more than happy to share more in-depth information as to the X-ray capabilities should you want to follow up thereafter.
Super. Thanks very much, Adam. Let me just get rid of the slides. Very informative. Thank you. And there are some questions, so we'll get straight into them. Question from Francis. Francis Wallington. Just hang on a second. What are the safety precautions for colleagues operating and verifying X-ray detectors?
It's a really good question. So when it comes to safety precautions, so the X-ray machines themselves, when they're manufactured, they're not allowed on site and to be turned on site unless they meet specific measurements when it comes to radiation emissions. So for example, an X-ray machine within Europe, with the exception of France and Belgium, the X-ray machine itself is only allowed to emit 1 microsievert of radiation per hour. That is a European limit. This changes when you go to North America, where it's 5, and Asia has some regional differences as well. When it comes to individual precautions, so if we take the UK as an example, if you're bringing a X-ray machine on site, you have to notify the HSE, the Health and Safety. You also then have to anoint a designated champion to go through what's essentially called training for, and at the end of it, you would basically get what's classified as an radiation protection officer. That individual would then be responsible for periodically performing a radiation check to make sure the machine is operating within the values that it stipulates within regional legislation. For the majority of individuals, the only precaution that you need to take is limiting the amount of time an individual is around the X-ray machine within a calendar year, which stands at 1,000 hours, so essentially 1 millisieverts worth of radiation. The 2 exceptions to that rule are individuals that have pacemakers and are pregnant, and at this present moment there are no specific values for what those individuals can do. There's not been any in-depth studies into individuals with those 2 specific criteria. So fundamentally, and to give you some level of context, I mentioned the example of an individual going and having their chest X-ray. An individual that has a chest X-ray would be exposed to 20 microsieverts worth of radiation. That's the same as standing next to an X-ray machine in a manufacturing environment for 20 hours. So from that very short exposure to radiation as part of a safety check on our own bodies, you are essentially being exposed to significantly higher levels of radiation during that routine appointment. And this means that, and hopefully gives an example, that the X-ray equipment, while there is obviously, it has lots of safety stickers on it because it is a radioactive source, the levels of radiation that are permitted are very low in context with everyday activities that we would necessarily do in our day lives.
Yeah, that's a great answer. Thank you. Another question from Francis. What are the means of verification of operation of a detector? How can you verify?
So if we mean the operation in terms of the ability to detect a foreign body, one of the key ways would be is to perform a performance verification routine. And this is where you would necessarily put a test piece of whatever designated material that you have agreed upon with the necessary X-ray manufacturer, and you would pass it through the X-ray to ensure that that foreign body is detected. In terms of means of verification, the operation of the detector, from a system functionality, at the beginning of the day, you could generally run a calibration of the machine, which obviously tests the relationship between the generator, which is one of the core components, and the detector, which is the other element which produces the image. And obviously, as long as that calibration process passes, then you have the ability to verify that those 2 core components are working in parallel and therefore you can run the machine in operation. So hopefully, depending on sort of what you meant by verification, those two answers clarify that for you.
Excellent. Question from Harvey. We are canned tuna manufacturers. We only have an in-process inspection, which is metal detection. Is the X-ray inspection also applicable to the canned tuna product in our end offline process?
So the answer is fundamentally yes. So as I mentioned, X-ray inspection is all about density. So the good news is an X-ray beam can penetrate the tin can and inspect a tin of tuna. The one thing with particular, when you start looking at packaging of high density, such as metal and glass, one of the things it's better to necessarily do is have a machine inspect a product when it's sealed, but what we would not classify as the final good. And generally speaking, the final good in a tuna environment, and correct me if I'm wrong, would be a multi-pack that would then ultimately go to a retailer. So for example, it might be 4 tins within a flow wrap sleeve that might equate to, I don't know, 400 grams, 100 grams, whatever it may be. So to answer your question, X-ray can inspect both of those packaging types, but generally speaking, you will always get the best performance inspecting an individual product. And this would be where necessarily, while you could inspect a tuna can at the end of the line, it would be best to do it before it goes into multi-pack packaging and then off to logistics for shipping to the necessary retailer. So you can inspect it when it's, the tuna itself is within the metal can, it's been sealed, but you generally want to do it prior to what we would classify as the final product to get the best performance possible.
Yeah, makes sense. Another question from Francis. Is the software an essential component of the X-ray machine?
Well, fundamentally, yes. So your 3 core components, you've got your X-ray generator, which produces the X-ray beam. This is obviously fundamental to the workings of an X-ray system. Then you have core component number 2, which is the detector. And this ultimately takes the energy, the signal that it receives from the X-ray beam, and turns it into an image. And then the final core component is obviously the software, which is then responsible for the inspection algorithms, which then determine whether something is good or bad.
Okay, got it. Juan is asking, do you have an example of finished products with various inclusions? Is there anything available on Metal Toledo's resources, white papers, anything like that you know?
Yeah, so, and again, it depends on what they necessarily mean by an inclusion. So, for example, we do have a lot of examples of goods where we've done inspection for various different things. Obviously, it's going to depend on what they mean by an inclusion, whether that be a foreign material or whether that be another item, for example. But yes, we've got lots of examples that we can share. We've got product test reports for various types of material, which we have done testing on. We've also got examples of various different quality checks that we've also done. So one of the things I'd necessarily invite Juan to do is obviously, if they can specify either in the chat or to us afterwards, the exact inclusions that they're looking to identify, obviously we can be a bit more specific in the type of example that we can provide.
Okay, great. Another question from Harvey. What's the correct approach to metal detection? What is the correct approach to metal detection verification or X-ray? Sorry, what is the correct approach to metal detection verification or X-ray inspection? Should the test pieces be run alongside the product during verification or separately? Is there a sensitivity variation on these two methods?
So in terms of what is the correct approach is to perform what's either, so in the metal detection world, it's sometimes called a PV, performance verification. In X-ray, it's sometimes called a PVR, which is performance verification routine. So that is fundamentally the correct approach when it comes to verification of your equipment online to ensure that it is detecting whatever the agreed value might be and agreed material. In terms of the test piece itself, that should be included in your test pack. Now, a test pack could either be something that's been made up that resembles the product so that you can do it, within weeks and months, especially if it's a perishable good, so you're not doing essentially destructive testing where you need to bin it thereafter. But the test piece should always be inserted within the product to ensure a reliable performance verification routine. So it would not be advisable to necessarily have the sample after the product.
Okay. Ravi Kumar, can install in the raw material handling in order to avoid final product screening.
Yes, absolutely. And actually, this is one of the growing areas in which X-ray inspection is being utilized. Because if we take the example of agricultural goods that come in from a field, whether it be an item that's grown in the ground or something that's been harvested by falling onto the ground, one of the key risks is going to be stones. And of course, we want to remove those stones prior to the manufacturing process, especially if we've got cutting blades, which obviously with interaction can shatter, can break, and then you've got multiple sets of problems. So what we generally have from an X-ray perspective is a machine, what we would classify as a bulk inspection product. And this would be where, for example, you could have a conveyor, which then feeds via a hopper, an X-ray machine, and essentially you are then feeding whatever that raw material might be, whether it be nuts, whether it be pulses, whether it be grains, whether it be poultry, for example, onto the X-ray conveyor, unpackaged. It would then be inspected for whatever the potential risk might be. So stones for agricultural, for example, bone from a chicken perspective. And of course, these materials can then be removed from the machine prior to going upstream and having more value put into them by the nature of the processing environment, whether they be cut, cooked, added into whatever it might be. And this is the fundamental challenge for food manufacturers, is that generally speaking, critical control points are at the end of the manufacturing line. However, what that means is you are generally rejecting a final product which has lots of value in it. The actual product and all the things that have gone into it, cooking, mixing, for example, plus the packaging as well. Whereas what is a growing trend is to actually inspect at the beginning of the process, move as many risks as possible, which is therefore going to de-risk what can physically get into the product during the further upstream process. So to answer your question, absolutely. And generally speaking, if you're going to look at X-ray inspection, look for the word bulk X-ray, and that will take you to the type of inspection system that is designed for raw goods coming in to the factory.
Okay, great. Thanks, Adam. Juan's come back and said, do you have an example of finished products with various inclusions, ingredients, chocolate chips?
Yes. Okay, so that makes, so for example, yes, we've got applications where we've been doing, for example, cereal bars, health bars, and of course, these would then include things like chocolate chips. And depending on what you're looking to understand, the answer is, can we count the chocolate chips? Well, the answer is that's going to depend on how they sit inside the product. If you're looking at understanding whether we can do foreign body inspection and ignore these chocolate chips, the answer is absolutely. So what you generally do with the X-ray, you have to teach an X-ray what good is before it can identify what bad is. A bit like AI, for those of you that have potentially looked into it, you have to teach an X-ray. So if you pass in the product that has the inclusions, the X-ray will learn that these are good, these are not bad. And therefore, it can then perform foreign body inspection, ignoring the inclusions that are already in the product.
Just on that point, are you already using AI in X-ray, or is the plans and things like that?
It is definitely being looked into in the ways that AI can provide additional benefits when it comes to X-ray inspection.
Okay. Sige, can we verify X-ray itself before it starts, and how often do we need to verify it? Another thing, can we use X-ray inspection in peanut butter manufacturing factory? If so, at which point?
So the answer, I'll split the answer up into multiple stages. So how would you verify the X-ray? So again, there are two ways. You would run a calibration at the beginning of a shift or whatever it may be at the beginning of a day. That's obviously going to verify that the generator and detector are working. The other way in which you can verify it is to ensure you're doing PVRs, these performance verification routines, in a timely manner, which of course is going to ensure the performance levels are maintained because you are testing to make sure you're achieving them. To answer your question about peanut butter inspection, the answer is absolutely. And we have machines in the field that are inspecting peanut butter in plastic packaging, but also glass packaging as well. Now, again, going back to the point I made earlier about the density of packaging, you generally would want to inspect peanut butter during what we would classify as the in-process part of the inspection of the product processing environment, in the sense of you want to inspect it in an individual jar, whether that be, for example, plastic or metal, rather than a 12-pack or whatever goes into the final wrap before it goes to a retailer. So we would generally place machines in process in a peanut butter manufacturing environment to ensure you get the highest level of performance inspecting an individual jar rather than a case. So again, if you do want to find out more, we do have someone that works on the continent of Africa that can provide you with more information as to the type of solution that we could implement, depending on your packaging type.
Okay, great. Fahad, is X-ray inspection applicable for the detection for detecting foreign bodies in nicotine pouches? Currently, we have a metal detector in place.
So fundamentally, the way X-ray works is that in order for a foreign body to be detected, it has to be denser than an item than the product is sitting in. So for some level of context, generally speaking, most food-based items have a specific gravity of 1 centimeter cubed, for example. Stainless steel has a specific gravity of 8 centimeters cubed. Therefore, obviously, there's a considerable difference in density, and that's why, for example, that material can be detected, generally speaking, in quite small sizes. To answer your question, we'd need to determine what you mean exactly by foreign bodies, because, of course, foreign bodies can cover a wide range of different things. I gave some examples earlier: metal, glass, stone, bone, for example. But if you could specify, again, whether now or later on, what we'd be able to do is perform a product test. We perform a free of charge product test offering from various different centers around the world. And if you tell us what you'd like to find, we can perform a test and tell you whether we can find that specific foreign body or not. The general rule with X-ray is that if it floats in water, it is not detectable because it hasn't got a greater density than that 1 centimeter cubed value that I mentioned earlier. So this is going to cover some material like human hair, insects, wood, for example. We know wood floats. We've been sailing on boats for thousands of years. However, any material that can sink in water, we can potentially find. And this is where, again, we can potentially run that test for you with your potential challenge and tell you to what value we can achieve foreign body inspection.
Brilliant. Sharan is asking, what would be the approximate cost difference between a metal detector and X-ray for a plant to consider it for CapEx? Like, is there a ratio, rough?
There's not necessarily a ratio, but again, it depends what you're comparing it to. Because if you're comparing it to just a metal detector head, then there's going to be a considerable difference. If you're comparing it to a metal detector with a conveyor and a reject station, which is generally what an X-ray has, it's generally then for a lot closer. So, for example, if we take the UK as an example, you could be, and obviously there's going to be some variation, but you could be looking at a metal detector with a conveyor and a reject, anything from the range of £15,000 to £25,000.
Okay.
And a lockable bin could be anything from, for example, 30 to 50,000. So it can vary depending on the full configuration. Sometimes it could be double, sometimes it could be triple. It very much comes down to what you specify the equipment to have in terms of options, and also some potential components such as requirements that you might have to make a machine non-standard to fit your manufacturing process.
Got it, yeah. Okay, question from Boone. Are there any compounding radioactive level on irradiated food?
So the fundamental answer is no. So obviously, I touched on it very briefly, and we've got some white papers on this, but the WHO, they did a study where it said that the amount, how quickly the food is passing through the machine fundamentally means that there is no the food doesn't become radioactive. Now, if you were to pass that food, obviously 5, 10, 15 times, generally, again speaking, there's going to be a build-up, but the X-ray values are so low that fundamentally there is very little risk of that product become radioactive. And also, if you're having to pass the same product through 15, 20 times, there's either a fault in the process because you're having to repeat, or it's contaminated, which at that point you should be looking to destroy it anyway as part of a retailer code of practice.
Okay. Jeff is asking about challenges with glass jars.
So there are numerous. So fundamentally, number one is the shape of the glass jar. So of course, round jars are the easiest because generally speaking, they have the most similar level of thickness around the entirety of the product, with the exceptions of whether it be a jar. Generally speaking, you've got a shoulder and a base, which is generally thicker. If you're looking at a bottle, you've got, depending on what it is, but you've got a base, you've got a shoulder, and you've also got a neck as well. So depending on the jar itself, you've got the variation in thickness of the glass jar on the wall, and then you've got areas which are potentially challenging, which is obviously the lid area, especially if it's a metal cap. You've got the neck area just under the lid, you've got the shoulder, and then you've got the base of the jar. So these are your challenging areas. The other element of the challenge is, of course, you're looking to find the same material that you are potentially packaging the product in. So generally speaking, foreign body detection is larger than if it would be compared to metal, for example, because not only does glass have a lower density value, 2.5 centimeter cube compared to 8 of stainless steel, you're also having it to be sizable from a density perspective, different to the packaging itself. So fundamentally, there are challenges. However, that does not mean that we don't have solutions. So, for example, we do have various machines around the world inspecting glass jars and bottles and can perform glass in glass inspection. So there are challenges, but the good news is a lot of those can be overcome. But it's also important to understand you won't achieve the same level of glass foreign body inspection as you would be to denser materials like metal.
Okay, super. 3 more questions. We are quite a bit over, though we did start late, to be fair. Sharon, the final packaging in the fruit pulp industry is in LDPE bags packed in plastic drums, which are of 200 litre to 1,000 litre capacity. Are the X-ray detectors available to detect finished goods of this large capacity?
So it'll depend on the type of X-ray machine that you're looking to implement. So for example, there are X-ray machines in various different types of industry. So for example, we manufacture, generally speaking, for the food and pharmaceutical industry, but there are also X-ray machines for airports, which I'm sure the majority of you have seen if you travel. You also have X-ray machines that are utilized at ports inspecting containers. So in answer to your question, there might not necessarily be a standard X-ray from a food manufacturer that can deal with a product so large. However, generally speaking, there are X-ray machines that can inspect very dense items like a container coming off a boat. So to answer your question, X-ray technology, yes, necessarily can inspect large items like this. However, obviously, there are going to be potential challenges such as the type of X-ray you're going to need is going to be limited based on the sounds of it, how large the item is going to be and therefore how dense it's going to be. And then also the type of foreign body you can then find is going to be significantly reduced. Going back to that point of density, the foreign body has to be denser than the material that you're inspecting. So it's generally speaking going to be quite a large item of quite high density in order for it to stand out in something that big. So I'm not saying it's not possible, but there are some significant challenges. Another way you could potentially do it is you could look at implementing a pipeline solution earlier on in the process before it goes into the final drums. What this would mean is you'd pump the pulp in through a network of pipes. It would go through an X-ray inspection system, which could then inspect potentially down to 1 millimeter stainless steel, for example. And then after the X-ray, it could go into these plastic drums. And therefore, you would then be eliminating the potential risks. It's going from the X-ray straight into the drum. And also being able to inspect potentially down to very small sizes. And this is one of the ways which if we talk about the various stages of the manufacturing process, it would mean that you would be able to meet your requirements potentially to a food manufacturer, but also ensure your finished goods are very safe as well, depending on where they go next. So in that size, you're going to struggle. However, there are ways in which you could go about it.
Great. On how to verify the X-ray machine when we have products are defective by metal, but the X-ray machine was not detected the metal. Does that make sense?
So basically, and hopefully I understand the question correctly, it's very much about whether the metal, so the X-ray machine has missed a metal contaminant. How do we verify that it can actually find metal? Well, it comes back to the point of density I mentioned earlier. So the foreign body has to be denser than the product. So for example, if we take a generic example, which could be a block of cheese, theoretically, if we take a 500 gram block of cheese and for whatever reason, we verify the X-ray can perform at a value of 0.8 millimeter stainless steel. If we then put through a test card at 0.5 millimeter stainless steel, we're under our threshold of 0.8. So that would potentially be not detected at all, indefinitely. Now, a way that you could verify the machine is, again, if you have a standard, like in this example, 0.8, it would be to run a PVR, put your 0.8 mil sample on the product, pass it through. If it's detected, then you verify the machine can perform against the necessary criteria. And again, generally speaking, there are retail codes of practice that stipulate this. For example, there are some in the UK that will say if your product is between 0 and 25 millimeter in height, it has to be 1.5 mil metal. Well, in this example, we can meet that retail requirement at 0.8. But the way that we validate that is by a performance verification routine.
Okay, super. Last question from Francia. X-ray tube generator is a consumable part of the X-ray. Roughly how much is the cost of this consumable part?
It's going to depend on the manufacturer that you speak to. So, for example, some manufacturers, you can replace just the X-ray tube, because you're right, that is what we necessarily would say is a part that fails. And generally that fails over a period of years, which is why we offer a 5-year warranty. Now, necessarily ourselves, we don't swap out the X-ray tube, we swap out the whole generator, because then you can guarantee the control system and all the other elements such as cooling, which ensure the generator's smooth running conditions are at optimum levels. So the cost will vary considerably based on the approach of whether you do replace the tube or whether you replace the whole generator. So that's very much a question with regards to the specific manufacturer that you necessarily might be speaking to as to the approach they take, and they'll be able to provide you with a relative cost. But generally speaking, the X-ray tube is it's the primary core component, and it's generally also one of the more expensive components to replace of a system. Okay,
brilliant. That's amazing. We've run over, but you've answered every single question immaculately, very clear. And in fact, Nathan has said, Mr. Green, have you thought about teaching in academia? The way you describe and explain is unique and completely digestible. So there you go.
That's very, very kind of you. Thank you very much. The answer is no. But it's a pleasure for myself to be able to join events like this, and hopefully the attendees find it informative. And of course, we run periodically events like this throughout the year, going into some more niche applications, like we run a specific one on canning, for example. We run specific ones on meat and poultry to help manufacturers understand in those more specific areas rather than more of a generalistic topic such as we've been presenting today. So we would be more than happy to see you at another event, whether hosted by today's gracious host or alternatively through our own channels, to provide more information on X-ray inspection and how it can benefit the food manufacturing industry.
Super, brilliant. All right, thanks very much for your time today, Adam. First one of many with us, I'm sure. Everybody, I've loaded your certificate in the sidebar. We'll be following up shortly with an email with the recording and slides, etc. But for now, have a nice week and enjoy the rest of your day. Take care.
Thank you very much all.